Viruses, molecular pirates.
"35 million people are currently infected with HIV. Foot and mouth disease costs the cattle industry $5 billion a year in annual production loss. And there are over 200 million people currently suffering from hepatitis. And over 1 million of those people are going to die from it this year alone. Plainly stated, viruses pose very real threats to both our economy and to our lives. So why are viruses such an issue? I mean, we've been treating bacterial infections since the First World War. You think that with all of our modern medical technology, we'd be able to get a handle on viruses. Well, this problem stems from the fact that viruses are pirates. And yes, I do mean the Captain Jack Sparrow type of pirate. You see, when a virus infects your cell, it's a lot like a pirate hijacking a ship. They take the crew hostage, and for all intents and purposes, this is now a pirate ship. You see, when a virus gets into your cell, it takes control of all of your protein-making machinery and makes a whole bunch of more viruses, which go on to infect more cells, and so on and so forth. And so, this leaves us in an interesting situation. How do you stop viruses from replicating when they use your cellular machinery to do it? That is, how do you specifically target a virus without accidentally targeting yourself? And I mean, there's always the nuclear option. If you sink the ship, there's no more pirates. However, in this metaphor, we're the ship, so we tend to go for less lethal options when it comes to health solutions. Additionally, you could stop the pirates from boarding the ship. But in order to do that, you have to understand how they're boarding the ship. It's like saying viruses infect cells, and we know certain viral molecules are involved, which is like pirates hijack ships, and in some capacity, swords are there. If you can figure out how the sword works, you can figure out a way to disable the pirate, stop him from hijacking the ship, or stop the virus from infecting the cell. And that's exactly what my research is about, looking at these viral swords as they interact with our cellular components in real time. By attaching fluorescent dyes to these molecules, we can observe them interacting with our cellular components on the molecular level. Now, you can look at things like how these molecules interact with each other. You can look at things like how tightly they interact with each other and the number of steps that are involved in each of these specific interactions. Once you have all of this, you can develop a hypothesis about how this viral sword works. And then you can start developing anything from antivirals to gene therapies to try to stop this viral sword from functioning. Because that should be specific to the virus and leave yourself perfectly fine. So now, we've disarmed all the pirates, they can no longer hijack ships, and it's nothing but smooth sailing from here on out. Thank you.